So thanks again, everybody, for coming out. We have volume, yay! So I'd like to introduce Kathy Heise, who is our expert for this evening. She's come all the way up from Vancouver Aquarium and has an extensive background in marine research and conservation. She's been involved in research on whales and dolphins since the mid-1980s. Over the years, she's worked to highlight anthropogenic noise as a critically important component of water quality and one that we have a responsibility to manage. So I'm going to let her talk to you all about that. Please welcome Kathy.
Thank you, Katie, and thank all of you for coming out tonight, and thank you for inviting me to come up here. It's really a pleasure to be here with you this evening. So what I'm going to be talking about is not exactly what the title is, but this is what it was advertised to be: Whales in an Ocean of Noise, Acoustic Impacts on Marine Animals. I'll be talking about, okay, can you hear me in the back okay? Okay. Okay, what I'll be doing is talking about how a primer on how sound works underwater, because it's different than in air. And I'll give you a sense of how some of the sounds that marine animals make and why they make them. And I'll describe some of the anthropogenic or man-made sources of sound, which are really noise to marine animals, and some of the things we can do to mitigate that. And if you have any questions, if there's something you're not clear on, put up your hand, feel free. So I got my background in marine research by graduating from University of Guelph in the early 80s, when there were no jobs for marine biologists. So we went out instead and worked on a lighthouse. And we were really fortunate, because being interested in marine biology, what better place and to be divers and see the life around you. But we were approached by John Ford, Graham Alice, and Mike Big, for any of you who are involved in killer whale research. Mike Big is really the grandfather of killer whale research on this coast. He was brilliant and had so much foresight in his use of photo identification to identify individual whales. Anyhow, they asked us if we would put an underwater microphone, which is called a hydrophone, at the lighthouse, and listen for the sounds of killer whales going by, which we were more than happy to do. After a number of years of doing that, we decided we wanted to get more actively involved in killer whale research, and I ended up going back to university to do some graduate work, and was using my own portable underwater microphone. And this is a hydrophone here that you can see just lowering over the side, and focused my research on killer whales and Pacific white-sided dolphins. And one of the real motivators for me coming to talk to you about noise tonight is just a sense of how marine animals can be impacted by sound. So what I'm going to play for you here is an example of some killer whales. It's quite a nice recording. You'll hear them calling back and forth. You'll also hear some echolocation, which is what they use to detect their prey. And that's that rapid click, 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 click sound. Is that too loud? It's okay. Loud for me. Anyhow, you're going to hear that whales are calling back and forth. These are the I-15s, for anyone who knows anything about killer whales. And then you're going to hear a boat come around the corner. Oh, that's too loud. Sorry, guys. Anyhow, you get the idea, okay? I'm just going to switch over now. That's called acoustic masking, when animals can't hear sounds. Okay, so you get the idea. Your own hearing was just masked by my recording. So I'll give you this, hopefully, quick primer on underwater sound. It's 16 slides, and most of them are fairly quick. So just hang in there with me. I know it's after dinner and everything, and sound isn't the same as sexy megavertebrate whales. When you look at this picture, you know exactly what's going on, right? There's sound wave traveling. This person is communicating. Likewise, you know what's going on here. You know that the person is receiving sound waves. So we talk about this, how sound travels in waves. And I'm going to play you a video.
When an object vibrates, it pushes the surrounding air molecules into one another, starting a chain reaction of collisions through the air. These collisions travel in waves. When they strike your eardrum, it vibrates. This vibration is converted into electrical signals that your brain recognizes as sound.
Now, when you saw that hammer striking the rod there, you saw that there were actually little particles in there as well. Just bear that in mind. We talk about sound traveling in waves, but for some marine life, we also talk about particle motion. And that's a very difficult topic I won't go into a lot of detail on, other than to tell you that, as you will see in future slides, it affects some animals. We're not affected by it, but some species are. So sound travels in waves, or cycles per second, or the term that we use is hertz, and it travels as particles, the particle motion. Our human hearing range is between 20 hertz and, from when the time we're very young, 20 kilohertz, which is 20,000 hertz. We also talk about whether a sound is low frequency or high frequency. The more waves they are per second, the higher the frequency. So at the bottom end of the piano, those are low frequency sounds. At the top end, those are high frequency sounds. Now I'm going to do a little hearing test on all of you. And this is really fun. I do this with school kids too, and it's really fun because basically our hearing is as good as it's going to be until we're about 10 years old. And the older you get, the more hearing loss you get, the more you listen to music with your iPod loud, or your iPad, or your iPhone, whatever, loud, the more damage you do to your hearing. So what I encourage you to do is, if you can hear the sounds that are being played, put your hand up, and then look around the room, and with the successive increase in frequencies, listen to see what you can hear. I apologize for the grammar in this start of this clip, but it is painful. Boy, you guys are pretty good. There's very few hands up in the room right now. I guess I don't need to continue, but you get the, oh my goodness, okay. Wow. You guys have been good. You've been protecting your ears. For the rest of you, eat more blueberries, because blueberries help the antioxidants. They're very good for you. No one can hear this one, can they?
I can hear that one, yeah.
You can hear that one?
Yeah.
Must be an artifact as well.
Yeah, there's something else in there.
Anyhow, what's important to know when we talk about sound is the lower the frequency, the farther the sound can travel. So in this particular graph, on the horizontal axis is distance from 0 to 1,000 kilometers. On the upright axis is how much that sound is lost, measured in decibels. And you can see a 100 hertz signal hardly loses any energy over 1,000 kilometers. Whereas at 1,000 hertz, which was the first tone I played for you, that sound level does drop off at 1,000 kilometers. At 20, or let's say 5,000 hertz, it drops off even faster. So that is attenuation.
Are you talking about in water or in air?
This particular figure is in water, but the same principle applies in air as well. When we talk about sounds, we also talk about whether a sound is narrowband or broadband. So I'll play you a killer whale whistle, which is a narrowband sound, followed by pile driving. And everyone could hear that, I'm assuming. Okay. So this is pile driving. Okay, it's fairly, it's quite broadband and it's fairly irritating if any of you have ever had to be around it for any length of time. Now, we also talk about the amplitude or the loudness of the sound. So when you look at these sound waves traveling here, the bigger the wave, the more amplitude it has, more energy. And we use the logarithmic scale, it's a decibel as the unit of measure. So in air, the very minimum threshold of our hearing is 0 decibels. A whisper at 1 meter, 20 decibels. And normal conversation, so my voice right now, if it wasn't amplified, would be about 60. It starts getting painful for us at 130 decibels, and jet engines can be very painful. So in the air world, for us humans, we've actually come up with noise exposure criteria. They've been in place roughly since the late 60s, and they haven't changed a lot over that time. But we can listen to 85 decibels in the workplace for 8 hours a day with no apparent hearing damage. You increase that to 15 decibels, and your exposure time is reduced to 15 minutes. So these scales are logarithmic. That means they increase in intensity very quickly. Just 3 decibels of increase in sound means you're doubling the intensity of that sound. A really important lesson, though, is that sound levels in air are not the same as sound levels in water. So if someone tells you that that ship over there produces 120 decibels, if you were in air, you would be concerned about it, but it's actually 149 decibels in water to be the equivalent measure. It's a 29 decibel difference. Anyone familiar with the Batholiths project? No, okay, I won't go into it. But there was a lot of, I'll just say that a lot of NGOs got involved during the Batholiths of the proposal for seismic surveys. And they were, as you advocate for the ocean, make sure you know what units are being used so that you advocate for sounds that are measured in water with the appropriate units. And if any of you are thinking of doing that, I can talk with you more about that after. So light travels much more efficiently in air than sound does. And now in air, sound travels at 300 meters per second. And in air, light travels at 300 million meters per second. And we know this because everyone, when you see a lightning strike, lightning fork, you see it and then you count the number of seconds, and it's about 1 kilometer for every 3 seconds. But the speed that sound travels at very much depends on the medium, and it's not as straightforward when you're looking at environmental impact work, because I just gave you the measurement of sound in air and water, but in sand, clay, sandstone, granite, limestone, look at those speeds. Sound travels much more efficiently in substrates like this or in steel than it does in water even. Okay. Enough of that. You sort of got your quick primer, and we'll shift back to, okay, well, what about the animals, and how is sound important to them? So I referenced Mike Bake, who developed photo identification. We know each whale on the coast. For those of you, some of you might have gone to Tessa Denlanco's talk a little while ago, but I'm assuming most of you didn't. Hopefully you know there are 3 different types of killer whales on the coast, and they use sound differently. The most commonly seen killer whales for most people are the resident killer whales, and they're the fish-eating killer whales. And they use sound all the time. Like the clip I played for you earlier, they're actively calling back and forth to each other and echolocating. So they feed on fish, and they don't worry about making noise at all. One thing that I will show you here, we've got the northern and southern resident populations of killer whales. This is the area where they are ranging. But what's really great is that, at least for a portion of their critical habitat, it's been identified, and our government recognizes this. And the southern residents are an endangered population. This figure shows you their critical habitat. The government is required by law to protect that area, and it means to protect them from acoustic disturbance as well as other disturbances. Now, the critical habitat does not extend into house sound, but any vessel traffic coming into House Sound is presumably going to be passing through southern resident critical habitat as it goes out to market. Now, the second population of killer whales are the big whales. We're now naming, we've for many years called them transient. Mike Big came up with that name, but now we're trying to switch that name over to big whales in honor of Mike, but also recognizing that transient killer whales they're very regular in some ways. Yes, they travel through an area and you don't see them for long periods of time, but they do routes and travel much of the coast. And this is the range of in red, of the transient killer whales that we typically see here in BC. And what's special about them is they don't use sound actively, they use it passively. They have to listen for the sounds of their prey. They have to be able to hear a porpoise surfacing or a seal or a sea lion. So they are generally very difficult to detect with underwater microphones or hydrophones. So as a way of assessing their population, we can't rely on them calling. We actually have to go out and photo ID them and quantify numbers that way. But I'll just play you a sound. The only time when we get any good recordings of transient killer whales is after they've killed something. And then it's, in their world, it's like the table is set, they're eating, but I find it a very haunting sound. And the third population of killer whales that we have are what's known as the offshore killer whales. And we actually know very little about them, but they travel much like the resident killer whales. They're communicating back and forth, lots and lots of echolocation and calling. They range all the way from Western Alaska down to California. They travel incredible distances and they rarely come inside waters, once or twice a year, maybe. What's different about them is they prey on sharks. And if any of you have ever felt a shark, its skin's quite rough. Well, for the offshore killer whales, if one ever washes up ashore, we know right away. And that's because from preying on these sharks, their teeth are braided and they can be worn down almost, well, with older animals, completely down. So it's an interesting evolutionary strategy here of these separate niches that these three populations of killer whales occupy. So the group that I've probably spent on my own the most of the time working on are Pacific white-sided dolphins. How many of you here have seen them here? Yeah. Good number, okay. And I'll play a clip for you. We call these guys killer whales on helium. Very frenetic, but you cannot be grumpy around these animals. Now, I'm actively involved in research at the aquarium on the dolphins there, but I've spent a lot of time studying them in the wild too. I can just tell you that this animal, we see a visual display. He's also making an acoustic, or it's making an acoustic display as well. This animal jumped up and down 17 times. That's the only way I could get that shot. Just kept pointing and hoping I'd get lucky. But the other animals in the group can hear those multiple slaps on the water. So again, think about how animals are using sound. So in the research that we do at the aquarium, what we're doing is we're actually blindfolding the dolphins with these eye cups. And these eye cups are made out of gelatin. I just put food coloring on them to make it more fun for me when I'm making them, because it's boring when you're making them all the way. But what we do is we get the dolphin acclimated to having the eye cup on. This is Laverne, and get her used to it, because dolphins aren't used to having things on them, so at first they're not too sure about it, but eventually we reach the point where we can put it over their eyes. And then we have hydrophones in the water and we're looking at their echolocation, and we're putting objects in the water while they're swimming around blindfolded to see how their echolocation may change. And one of the things that we do is, with the dolphins blindfolded, we actually ask them to retrieve objects. And so here you see Hannah, and you see the little ring that is just off of her beak there. I'm going to actually play for you a video clip showing you how exquisite their echolocation is, just how good they are at seeing underwater by using sound. So the trainer's just putting the eye cups on, and the ring have already been thrown into the water. There are 4 of them there. So you're going to, once the dolphin has both eye cups on, the trainer runs her finger up the dolphin's chin, and that's the signal to go retrieve a ring. So she's just about to give the signal here. Okay, off she goes. And she's actually scanning the water. She's got one. Okay, so if you think that was just lucky, I'm just going to play the second ring and you can see her retrieve that as well. She cannot see a thing. They actually close their eyes before the eye cup goes on. She's just echolocating like crazy. There she goes. She's scanning back and forth, and she's found another one.
So what sort of frequency is she using?
That's one of the interesting things that we're finding is she adjusts her frequency. So they go up to at least 80 kilohertz, so quite high frequency. And they go down to, well, my equipment, I'm picking up probably 20 hertz. So it's quite a broadband sound. So just because I'm here, I thought I'd just focus on what I think. I think the herring story for house sound is wonderful, and I think the dolphin story for house sound is wonderful. There were no sightings of Pacific white-sided dolphins in house sound until 1995. For the whole 1990s, there were 2. Then, 2000s to 2010, 9. 2010, what are we at? 72, and the numbers keep growing. It's a really wonderful thing, and I'm really pleased to have them here, and I think that there's actually a resident population of dolphins that moves in and out of Howe Sound and up into Malaspina Strait and into the northern Salish Sea. I'll just make a plug here. I know there was some from the aquarium there, but if you happen to see any cetacean, any whale or dolphin, porpoise, we really appreciate getting sightings, and it's actually been a very useful tool for us to get information about changes in distribution and abundance. But that's not why I'm here, so I won't go into it too long. Now, we have also on the BC coast, Dall's porpoises and harbor porpoises. What's different about them? They use sound and they produce sound, but it's all very high frequency. We can't hear it. So I'm going to play you some of their echolocation. And it's been slowed down, and I'd like you to listen to how close those clicks are when you hear it. And think about, if your brain works that way, the signal processing speed that these animals must have in order to actually be able to get information from them. This is slowed down, I believe it's 10 times. So there's information in every single one of those clicks that porpoise is hearing. So it's amazing. So the large whales, the baleen whales, the whales that have no teeth, they also use sounds to communicate, but they don't echolocate actively. So minke whales, for those of you who've ever seen them, they have quite a low frequency sound, and I'm going to play it for you. It's been sped up in order for us to hear us, because we don't hear those lower frequencies very well. Kind of a weird sound, right? Killer whales make nice sounds. These ones are Another fantastic thing that's happening on the coast is we're seeing a return of humpback whales. Now they use sound to coordinate foraging. And so they forage by making these bubble nets, if any of you have ever seen that in documentaries, and they trap the fish inside this curtain of air. And the males sing on the breeding grounds, which many people have heard of, and that's in Hawaii typically, or Mexico. But what's very cool is that we're now getting males singing here in BC. There appears to be enough of the population staying here over the winter and calling and socializing. So I'll just play you a quick clip of them. the male singing, and I think it was in February of a few years ago. So it's another low frequency sound. But what's kind of special about humpback whales and kind of neat about BC and Vancouver is that the very first whale watching industry in the world was right here, based out of Vancouver, and it was targeting a resident population of humpback whales. And they would take guests out from Vancouver Harbor out to Bowen Island and around there. And there was this was a winter time, they were resident, they were breeding here. So this return of humpback whales is really a reflection of we stopped whaling, we changed our behavior, the population is recovering. It's great. But what happened was in the commercial whaling was the whalers were always struggling in the winters about where to go. And some of you may have heard about them decimating gray whale population in the calving lagoons off Mexico. They actually came here. The Kate Steamship Company tried to block them. There are letters in the archives to the Minister of Fisheries asking him to not allow the whalers to come, but they did come. And in 3 weeks, they wiped out the entire population of humpback whales that were resident here, and also wiped out the first whale watching industry. Okay, another species that we see here, also a low frequency specialist, are the gray whales. And the real low frequency specialists are the large whales like fin and blue whales. Historically, their sounds could travel hundreds, if not thousands of kilometers in the ocean. And they use that sound in reproduction to attract mates, to coordinate behaviors. So fish and invertebrates also produce sound, and they use it for all kinds of different reasons. There's thousands and thousands of species, but I thought I'd play you one of the sounds that we hear, which is snapping shrimp. If you put lower hydrophone in some bays, it's the sound that you hear more than anything else. So they're just snapping their claws together, but that sound has a purpose for them. Now there are tens and thousands of species of fish, and over 700 are known to produce sounds. There's probably more than that, they just haven't been studied. But it was very interesting to learn. A friend of mine was doing research on the anti-predator behavior of herring, and he was out at Banfield Marine Station. And if you've been out there, there's a giant cable pool that was filled with water at that time. And he was typically doing his research during the day. But he went into the building one night, and he could hear the herring making these sounds. And no one had ever, actually that's not true, someone had previously reported in the literature, but it wasn't in people's recent memory to know that herring actually use sound. And they use it as an anti-predator behavior, is what Ben Wilson speculates. They called this sound fast repetitive clicks, or farts for short, and he got the Ig Nobel Prize in Science for this, but I'll just play you, and this is typical, it's not sped up, slowed down, anything. This is herring sounds, courtesy of Ben. So it's a squeaky, rusty kind of a sound, but anyhow, it's important to them. And this is a sort of an odd, scary-looking fish in a way. It's called a plain-fin midshipman. These are typically deeper water. They're found at 400 meters, but they come up into the intertidal to spawn. And Sarika Kala-Suzuki, who is David Suzuki's daughter, is actually just finishing her PhD on these guys, and she's looking at how they're impacted by noise. So unfortunately, I don't want to blow her big reveal of her results when she gets it, but I do want to make you aware, these fish make so much noise in a bay in San Francisco that residents were phoning the city trying to find out where the source of sound was coming from. It was irritating to the residents, and it was only at night. So quite amazing. And these fish, they're not that big, right? But what's part of what's what's neat about them is that the males are producing the sound to try and attract mates. And when they attract a mate, the males and the male and female build a nest. This is a mating pair here with the female on top. You can barely see the male underneath. But then the male stays after the eggs are laid and the female goes off. Yes. I knew someone would get pleasure out of that little fact. And unfortunately, I'm not at liberty to show you this video, but the little fish then uses acoustics to chase off any potential predators on the egg. So it's sound, and there's a visual display comes up, but he also makes a sound too. And I can say he in this case because it really is the males. So there's a hugely growing body of literature showing that some species of fish are sensitive to sound, and what the general thinking is that fish that have ears that link to the swim bladder are more sensitive. So codfishes are moderately sensitive, but highly sensitive species include carps, croakers, herring, shads, squirrelfish, and there are many others. But what we don't know is how eggs and larvae are impacted by sound. That's a fairly new area of research. There's some shows some species are vulnerable, almost like addling of eggs, and it's the particle motion that potentially could be the reason why. But that's a very new emerging field. Yes?
There was a diver not too long ago at the Fence Islands looking at herring eggs, and he encountered a huge sound from blasting, and he figures that that noise killed some of, if not all, of the herring eggs that he was witnessing.
Did he go back and look at the area afterwards?
Yeah.
It's this growing awareness. When we put sound into the water, we're having impacts. We don't always know which species, what time of year, whatever, but it's...
Jack, you might remember, Kathy was asking me before, there's an anecdotal story that during the Olympics, there was a ship and a generator there right through the winter, and no herring eggs hatched.
That's right. Well, no herring eggs were deposited because of the noise of that boat that lasted all through the Olympics during the herring spawning season. So they didn't spawn at all.
Did they have lights on all night?
Yeah, I think so, but I don't know if they went into the water or not, but they had the ship motor going all the time.
That's very interesting. So the take-home message is that sound is an important sensory modality for many marine animals, if not all. They use it for communicating, navigating, detecting prey, and avoiding predators. So, you know, I grew up in the 60s. This is one of my heroes, Jacques Cousteau, who really bestowed on people, you know, he wanted to excite people about nature because people will protect what they love, but he kind of blew it on this one topic. He made a movie called The Silent World, and hopefully you now get from this, the oceans are actually far from silent. A lot of the animals he was filming were probably making noise. So human-caused noise, though, is another issue, and it's why I'm here today. Because ambient noise levels, so the background noise level, is increasing and has been increasing every decade since the 60s in the Pacific, and it's about 3 decibels per decade. So it's a doubling in intensity every decade, and it's largely the result of our activities. Now, admittedly, for anyone who wants to argue, in the 60s, the fish populations were better off, and there was certainly noise from fish, and with commercial fishing, the contribution of fish to the ambient soundscape has gone down. Now that humpback whales are returning, they will make an increased contribution to the soundscape, but a lot of this is our activities, and a lot of these activities produce low-frequency sound that travels large distances. So with shipping noise, basically, the larger the ship, the more noise they make. And this is just showing you the super tankers at the largest, the large tankers, and then on the bottom, you're seeing a fishing boat. So you were going all the way from 180, 190 dB down to 140. And they all produce sound at low frequencies, and actually their signal goes up even higher than 1,000 hertz. Part of the reason why we see this increase is that we have seen the number of ships, that large ships, increase, basically tripled since the 50s. And the amount of cargo that each ship carries has increased sixfold since the 50s. So the ships are bigger and carrying more cargo, and this is really what everyone generally agrees is the source of the biggest increase in noise. So what I'm going to show for you, it's a little bit of a complicated figure, but it's based on PhD work done by Megan McKenna. And what she did is she put a hydrophone in the water 3 kilometers from the shipping lane, and she just measured the sound as the ship passed by. And so the center point of each of these figures is the closest point of approach as the ship comes towards the hydrophone, and then you see the noise level, and the color gives you the intensity of that noise. So we're going from 0 to 1,000 hertz, and you can, obviously, the more red, the more noise there is. So container ships travel quickly at 20 knots, a bulk carrier at 13.5, and a products tanker typically at 13.5 knots. And this was all looked at in the Santa Barbara Channel. What she found, though, that 10% of all her ships that she got, we call these acoustic signatures, 10% of them had weird harmonics happening. And that is related to vessel maintenance. So if a ship is well tuned, it doesn't have all these banging and clangings at different frequencies. But that's sort of what you're seeing here. So 10% of the boats made extra noise that they shouldn't have been making. So she found that with commercial shipping, blue whale call ranges were reduced 90%. So these are the species are historically, evolutionarily, their calls were adapted to travel hundreds, if not thousands of kilometers. And certainly was interesting finding. And this work has also been replicated in modeling work by Chris Clark. So this is on the East Coast, but it's just showing you, this is the communication space of fin and blue whales in the red circle. So historically, that's how far their sounds would travel. And now you're looking at the little red dot in the right-hand image of how far their sounds travel today. Well, what's making all this noise? The biggest source of noise on a ship is cavitation of the ship's propeller. So if any of you operate boats, you probably know, you go and you're chugging along and then you speed up and all of a sudden you start making bubbles underwater. These bubbles are not air bubbles, it's like a expansion of the space that creates the bubble, and then the bubble collapses. So what you're seeing here is the streaming of bubbles off of a turning propeller. Any vessel that has a damaged propeller is going to make more noise in the water. And if there's fouling on the hull, whether there's nicks or bends in the prop, and so this is something any vessel owner can do something about. Also, any machinery that's on the boat, that sound transmits through the hull. And if the big ships that use bow thrusters and things, those are very noisy because they're operating at full capacity all the time. The faster you go, the more noise you make. And especially for those of you who operate small boats, the ones that go in and out of gear all the time, that makes a lot of noise underwater too. What is also mitigatable, though, is that these commercial vessels show a 40 decibel difference from one, container ship A versus container ship T versus container ship Z. There's a 40 decibel range in how much sound they do. And if 16% of the loudest vessels reduce their noise by just 6 dB, there'd be a 60% reduction in insonified space. So there's been some really great modeling work done here on the BC coast looking at, okay, what are the noisy areas on the coast? So in this figure, blue is the quieter areas and you go up into the red. And if you look at this was done in 2008, and Christine Erbay and her colleagues used AIS data, so automatic information system that many vessels have for transmitting their location. And so she mapped all the vessels and for different size classes, looked at how noisy they were, and came up with this map. And not surprisingly, Lower Vancouver Island is a very noisy area. What was surprising though as well is in Hecate Strait to the east of Haida Gwaii. That's also very noisy. And the reason for that, Christine believes, is that even though there's fewer vessels going in and out of there, the characteristics of the water and the substrate, recall how I said that sound travels through limestone and things like that, but in shallow water it can bounce, so the sound gets trapped in that area. So I'm just going to play a quick video clip. This is a masking of killer whale calls that's been modeled. The ship's traveling faster than an airplane, obviously. This is the entrance to Kitimat, and this is the route that the tankers would travel. And so you're going to hear some killer whales and then followed by the ship. Very quiet. Can people hear that in the back? Or you're asleep? Probably should have put those in earlier. So now whales are now starting to hear the sound. Basically giving you a visual of what I played for you earlier, where the killer whale sounds were passed as the whale came around the corner. So what does all this noise do to animals? This chronic noise of shipping? Well, there's a lot of research that goes into it. A lot of people like to argue about does it have impacts or not, but unfortunately 9/11 gave us one of the greatest opportunities for what we call a natural experiment. So as you'll recall, during the 3 days after 9/11, there was no air traffic. Well, there was also very little commercial ship traffic at that time. So the ocean in the area around the Bay of Fundy, where people were studying North Atlantic right whales, was considerably quieter, 6 decibels quieter. What was the opportunity for the experiment was that prior to 9/11, during 9/11, and following 9/11, the researchers were collecting stool samples from the whales. So that's sort of a non-invasive sampling method, and measuring the stress hormone in the whales. And just in that 3-day window, just those 3 days, there was a significant measurable decline in their stress hormones. What does that mean for the recovery of North Atlantic right whales? We don't know. But you can imagine, we're trying to recover this population. It's another source of stress we're putting on them, and worthwhile thinking about in terms of how we impact them. Some other sources of sound that we put in the ocean are pile driving, which I played for you earlier, another construction noise. Dredging is very noisy underwater. Underwater explosions are really noisy. And one of the papers that I like to tell people about was there was some construction going on in Newfoundland many years ago now, but it was at a time when there were a lot of humpback whales in the area, and they were getting a higher rate of humpback whales getting caught, entangled in fishing nets. And 3 animals, at least, I'm not sure of the total number that were caught and died, but 3 of them were recovered and necropsied by a very famous bioacoustician, Darlene Ketton, and she looked at their ears, and they all showed blunt force trauma. So that happens from being potentially too close to the explosion at the time. Now you have to wonder, if there's construction going on, why are those whales there? Well, you have to look at the question, why were they there in the first place? They were probably foraging, and they were staying in the area because they wanted to eat. That's biologically, they're driven to eat when they need to. So pile driving is this source that I think we need to think a bit more about. They're driven into the ground, piles that you see putting in docks or for construction or what have you. They're typically driven in with impact hammers or vibratory hammers, and they they can be incredibly noisy and broadband. So what happens is the sound comes from the hammer striking the pile and pushing it down into the ground. But it also comes into waves that transmit into the ground and can, it's difficult to predict. It's very site specific how the sound waves will travel, but they bounce around and then they can come back up into the water and then back down again. So the largest piles are now being used in the wind farm industry. They're up to 7 meters in diameter, and there's talk of them going to 10. There's some good news on the pile driving story I'll get to, but the consequences for fish around pile driving are not good. They can cause ruptures and hemorrhaging, that sort of thing. And unless the species is of commercial concern, it's not a concern to fisheries. So we are at risk here of killing off species or injuring individuals, at least in the case of pile driving, if we're not careful about how we mitigate it. We also know that it displaces harbor porpoises up to 30 kilometers away, and they will leave the area. It's not unlike the humpback whales that stay even when it's noisy. The harbor porpoises are more sensitive to that kind of disturbance. Even though they're high frequency specialists in the sounds that they produce, the low frequency sounds from the piling are disturbing. So we don't have standards for pile driving in Canada. They're not national, they're just regionally applied. They're up to the each fisheries office, what proponents will be required to do. But a really great thing happened in Germany. They have national standards for pile driving there. And they said, okay, you are not allowed to produce more than 160 decibels of sound underwater for the installation of these piles. And wouldn't you know it, that regulation drove innovation, and Germany is now a leader in mitigation technologies for piling. It's a real lesson to us all. If a business or an industry wants something badly enough, they put their thinking caps on. So a bunch of different methods, and I'll just quickly say that air bubbles are because sound will not travel through the air bubbles as well. That's one common method, but there are many of them now. Seismic surveys are also a large source of noise in the ocean, and they are the predominant source of sound in the Atlantic Ocean. They're not in the Pacific and around our area because we don't have seismic surveys now, but if offshore oil and gas is ever developed, there'll be a lot of seismic surveying going on. And I'll just tell you that sound can penetrate up to 50 kilometers into the ocean floor and still return a signal back to the operators. What they're doing is they're towing an array of hydrophones, so they blast air from an air gun, and it bounces down, and the hydrophones pick up the sound energy that travels back up to the water surface. So it's a quick cartoon of it. And this is seismic surveys on the East Coast. You can see these are huge. They can be up to over a kilometer wide and several kilometers long. It's really noisy. This is just a map of some of the areas. It's an older map from 2009, but you can see how much seismic survey is going on. And we all know that the Arctic is now a target for development, and you can expect there'll be a lot more, well, there already is now seismic surveying going on there, and there will be more. What's challenging as a biologist is historically, people use behavior of animals as a cue to just try and tell whether the animal was being impacted. But it's really difficult to interpret that, and I liken it to going to a concert. They're the twit teenagers, like I was, who go and sit right next to the speaker. God knows what I did to my ears. It's probably why I don't hear 15 kilohertz very well. But then there are others who swim away. So you can't really use behavior as a metric necessarily that you're having an impact on animals. But there's a really interesting bit of work done, and this was on a study done in Australia by a person named Rob McCauley. What he did is he took a species of fish there called pink snapper. They're different than the ones here, but he put them in cages, and they were down not very deep. I think it was around 20 meters. And he he towed a very small 20 cubic inch air gun. He towed it from a skiff. So you saw the big ships, those air guns can be like 8,000 and more cubic inches. So it's a very small air gun. And he towed it over. He had a video camera looking at the fish in the cage while he towed it over. And he noticed that as the signal came close to the fish all startled. And then they settled down again, and he continued on. Then he did one more pass, but they didn't startle the second time. So what he did then is he kept the fish in the cages, and every 2 days he necropsied the subsample of those fish that were in the cages. And what you see here are the ears from fish that would normally be healthy on the left, and on the right, the ears of a fish that were exposed to this air gun. So all of the fish were effectively deafened by being exposed to this air gun. The reason why they survived is because they were in a cage. They were safe from predators. Can you imagine how well a deaf fish survives in the ocean? This was a paradigm shifting paper for me. When I read this, I was like, wow. There are alternatives to this technology, and again, this is being driven by regulation, and so companies are coming up with alternatives. So one of them is a marine vibricize. So some of you have also no doubt followed the stranding incidents that have occurred in different parts of the world using military sonars. These are they're relatively narrow band signals. We can have low, mid, and high frequency, but they're very powerful. And unfortunately, or for national security reasons, the US government hasn't been terribly forthcoming, and neither has the Canadian, about some of the details of these sonars. And there's legitimate reasons for that in some cases. But what is a concern is that it impacts animals by producing sounds, and we think with beaked whales that they may get the bends from this, being exposed to this. They're coming up to the surface too quickly. They've also been associated with mass stranding events of squid in the Mediterranean, and in the case of the squid, it's the statuses that are affected by it. There's an area in the Mediterranean now where they no longer allow military sonars, and since doing that, the number of beaked whale strandings has gone way down. So I'm going to play you a sound, but I'll do it really short because it's super irritating. But we had an incident here of the U.S. Navy ship Shoop, and now the operators on these ships are supposed to have marine mammal observers on board. If any of you have been around the southern Juan de Fuca area, Strait of Juan de Fuca, San Juan Islands, you would recognize that shape in the middle figure here as being a whale watching boat. Pretty obvious, okay? And yet this ship passed by with its sonars firing fully, and this is a group of killer whales. Now, killer whales are normally very conservative. They don't go in BC. The resident population does not go into shallow water areas under normal circumstances. But when these whales were exposed to the sonar, they went into the beached area, and then they did, which was very unusual, and then the pod split, which was also unusual. They just took off. There were a number of porpoise strandings around this time as well, and there were minke whales breaching at the time too. And if you spend any time around minke whales, they don't usually breach in BC. Or, well, yeah. And so I'm going to play the sound. This is a mid-frequency sonar. I'm cutting it short. It's awful. And I have research colleagues who've been up on the Central Coast and heard this sound, and they didn't know where the boat was, but it's such a powerful signal. They could hear it, and it was very painful. So are we mitigating adequately for this? Well, yeah. Anyhow, what we know about high energy noise is that it can disrupt behaviors, which is hard to interpret. It can mask communication signals and echolocation. It can block the ability of animals to just listen to the signals in their own environment. It can cause temporary and even permanent hearing loss, increase stress hormones and other physiological injuries. And it can cause physical injuries, as you saw with the fish, and mortality. What we don't seem to be able to address very well is what are the cumulative impacts of all the activities that we do. So here you're going to be assessing or looking at the assessment for the LNG plant. How does that relate to, there's also other proposals for other activities, the expansion of the coal port. These projects are all assessed separately. We never put them all together and think about what's that doing. There's a good news part of this story though, in some cases. In British Columbia, the people are listening. And there are over 50 hydrophones in stations on the BC coast, and that number is about to increase again. And a number of these are actually live streamed. You can listen to them on your computer. And we have both academic researchers and government researchers. John Ford has a number of hydrophones specifically for hearing killer whales, detecting killer whales and fin whales. But we've got citizen scientist groups, and I'll just highlight one of them for you. This is a group called Cetacea Lab, and they're up at the entrance again to Kitimat. They live on Gill Island near Hartley Bay, and it's a very unique lifestyle that they have. They're there year-round, and they have a system of hydrophones for listening. And as a result of having all these hydrophones in the water, they're able to monitor for the presence of whales, and they're also able to monitor for the presence of ships. And that's the model that we're moving to in a number of places now. Saturna Island is about to install extremely good quality hydrophones that can actually be used to collect legally defendable data on noise of vessels or sources of sound in the environment. And this group is getting some of the same hydrophones, and we're going to see more of that. People are waking up. Yes, we know we're putting noise in the water. The Metlakatla people near Prince Rupert, they're getting a hydrophone as well. So it's really encouraging. You can also go to a website called listentothedeep.com, and they have, this is run by Michel Andre of the University of Calais, Spain, and he has he is able to live stream a number of hydrophones around the world. Now, not all hydrophones are working all the time, but I can tell you, I spent days in my office this winter listening to the humpback whales off Barclay Slope. They were calling all the time. It was phenomenal. So it's a really neat way to gain insight into the acoustic world of humpbacks, or whatever species, sperm whales. Now, in the Stellwagen Bank, which is off Boston, they actually have arrays of hydrophones, and they listen for North Atlantic right whales. And so what you see here is an image. You have the small dots; those are vocalizing North Atlantic right whales, and the larger circles with the yellow or red insert, those are ships that are transiting through the area. And I don't know if it'll work, but they can actually be used, the video will work, sometimes does, sometimes doesn't, but it can be used to warn ships of where the whales are so they can avoid ship strike.
Excuse me, how do you locate them? Like you put a hydrophone in the water.
You triangulate them. So there's a series of hydrophones, and that's how they can do it. So yeah, you need to have at least 3, preferably 4. So you can just see the ships moving through the habitat. It's amazing what modelers are doing. So change is really in the wind. It's coming. Maybe for some of the species it's not happening fast enough, but it is. A bunch of scientists got together at a meeting in 2009 and wrote a letter to Obama. And that was responded to by Jane Lubchenco at that time. And so now they're actually incorporating sound into their marine planning processes and in their sanctuaries. We're not there yet here in BC, but awareness is growing, which is good. The International Maritime Organization is now coming up with guidelines on ship noise production as well, and even some of the mandatory guidelines that they are designed to improve energy efficiency will also help make ships quieter. And I like to use Europe as a model of really being at the forefront. They don't have the incredible network of 50 hydrophones or more on the coast that we do here, and yet the EU has come up with what's called the European Union Marine Strategy Framework Directive, where they have set a cap level for underwater noise exposure over the course of a year. And that The goal is by 2020, they won't be putting more than 100 decibels of sound into the ocean with the cumulative all of the impact of all the activities that are going on. And then there are a number of other organizations now, UN General Assembly, the IWC, et cetera. They all recognize that underwater noise is an issue. And so that European Union criteria of 100 decibels, if you look on the figure in the right, this is modified from the figure in the left that I showed you earlier, the modeling by Christine Erbe, you can see the areas highlighted in purple are where we're already exceeding that 100 decibel threshold right now. And this is based on 2008 when the economy wasn't doing as well as it is now, when there was less shipping. So we have no regulatory thresholds for underwater noise, and the only way we can invoke sort of protection is for SARA-listed species, if something is a threat to their acoustic habitat, and even that's a bit of a challenge. DFO, though, is drafting a framework to help evaluate projects and their noise impacts from shipping, and that's available as a CSAS document if any of you are biological consultants or following that sort of thing. And DFO also has what's called a Statement of Canadian Practice on Seismic, which is an ongoing living document that sets some guidelines for noise exposure. The other good news about this is that ocean noise isn't climate change. And there are solutions to this. And I think it's incumbent on all of us to ask any project that is being proposed that you have a good data on how much noise they're going to put into the ocean, and then you hold them to a very high standard for mitigation for the noise that they produce. And with that, if there's any questions, I'll take them. Okay, Nick.
What's the highest frequency that they use to communicate? Is it above 80 kilohertz?
Sorry, is it
The animals, the highest frequency they use to communicate, is it above 80 kilohertz?
It's very species specific. So porpoises, definitely, it's above. It can go up to 150. Whereas killer whales, it goes maybe up to 70, I think it is. And then you look at seals and sea lions or cod. For them, it's low frequency that they use, like below 1 kilohertz.
And the hydrophones, do you calibrate them for these frequencies?
Yeah, so that's what we're really moving in a great direction right now. These really good quality hydrophones that Cetacea Lab is getting and will go on Saturna Island. They're pretty much state of the art. They're some of the best hydrophones you can buy, and they are calibrated, they're time stamped, and they are, we call this flat. They're good from I think it's 2 hertz to 100 kilohertz. So you get a really good snapshot of what's going on there. And the reason why that's relevant, if you want information on fin whales, you've got to look at the low frequencies. If you want information on harbor porpoise, you have to look at the high frequency. These hydrophones can just sit in the water and collect data, and this researcher can say, okay, I'm interested in this, and then you just develop an algorithm so you can detect the high frequency clicks or whatever. So they're called ICVIS and hydrophones, but they're $20,000 a system, so it's a lot of money.
And how expensive is it to do the triangulation with the density and salinity of the water and that sort of thing?
How expensive?
For the speed of the location, for the speed of the wave. Is there a program for that, or is that just...
Those are adapted individually by individual researchers. So yeah, that part of it is new, but even just using 2 hydrophones and getting source levels on vessels, that's been done for quite some time now. And actually, there's a group, the Sailor Sea Hydrophone Network, Scott Beers. He's developed acoustic signatures for over 700 different commercial vessels on the coast. So
can you use the mic again?
Sorry. Okay. Do I need to repeat that, or hopefully not? I'll be louder. I'll tell you afterwards what. Okay. And yeah, there was a couple other hands there. Okay, the peace sign there. I can't see your face.
Can you comment on how well sound transfers between different mediums, in particular, say, a plane's flying in the air? how well does the sound intensity transfer into the water?
Okay, so the question was, how well does sound travel from the air into the water? It definitely does, but it's impeded partly, and I'm not a physical oceanographer, but it's impeded partly by that air-water interface. But, you know, for example, I've been at the aquarium recording underwater, the dolphin echolocation, and I can hear the float planes as they fly over. So, yeah. It's the sound that's produced in water or that bounces around with the substrate that's the largest concern, rather than the in-air transfer of sound, though. Yes?
Kathy, thanks very much. That's really informative. Could we take further advantage of your expertise and get some advice on what to do about the draft information requirements for this wood fiber LNG? Have you looked at it? Is there something that you would recommend that we should be asking for? In other words, work that needs to be done?
Well, I haven't looked at it in detail, but I did look at the proposal for the St. Lawrence for the floating facility there. And for those of you, I hope you know, are aware, the floating facility that they want to put in there, they want to put it in critical habitat for the endangered population of St. Lawrence beluga. And it's you know, I don't often speak out loudly on an issue like this, but it makes no sense to me why you would do that. Now, what you would want to know is, what is the sound produced by these processing facilities? I saw no information on that in the Quebec proposal, and you would want to collect baseline data over at least a year for what the characteristics are of the area in the first place, and also have them supply information on what sounds will be associated with the ships that travel in and out, the support vessels, everything. So I didn't see that in the Quebec proposal at all. Is it there in the proposal here? Are they even at that stage yet? Okay, that's what Owen can enlighten us about. So, sure. But no, it's appalling. Well, I'll give you an example here. Different companies come in and do different levels of baseline assessment, and I'm not a active proponent for it, but I'll say there's a company called British Gas that's proposing to put a facility in Prince Rupert. They've gone out and done year-round observing and having hydrophones in the water. That's the kind of baseline you should be doing. So they've got people in boats looking around, and also they're listening. And these companies that come in and have a hydrophone in the water for a few days, or maybe a week here and a week there, that's not good enough, because you know those plain fin midshipmen, they only make that sound during the breeding season, and then the rest of the year you don't hear them.
When do they make that sound?
I believe it's in the spring. And they're here too. So Sarika did all of her work on plain fin midshipmen around Gabriola. Yes.
I've heard that there are alternatives of an installation of wood fiber, one a floating one on a barge and one on the land, and there would be different sound emanations from either.
Yeah, I mean, anything that if you've got a facility, a barge is just like a boat. You know, any sound that's produced on board is going to transfer through the hull. So there is some mitigation that can be done for that. You know, the vibration mounts and things like that you can insist on. But to me, it's up to the proponent to say, how loud is this land-based facility compared to how loud this floating facility would be? Yes?
It strikes me to be useful to have a plot of the sort of frequency range that ships give off versus the frequency range that different fish or mammals or whatever use, to see how those overlap.
Yeah.
As well as having the input to it.
I can give you a figure that's commonly used. I could probably even find it here, but it might take me a while. And where someone's done just that, and they looked at the different source of anthropogenic noise versus the signals that marine animals make. And that is useful. I guess that the one caveat that I do have to tell you is the study that was done off California that compared the container ships and the tankers and bulk carriers, they were using hydrophones that only recorded to 1 kilohertz. So what we need to do is get acoustic signatures up above that. And just for those of you that power around in speedboats, you're making noise too. It's just that those speedboats, when they're going along at full throttle, tend to have high frequency noise is the dominant frequency. So I do have frequency spectra for an actual ship, so you could see where the power is. I have that as well. If you want to come after and give me a list of what you want, I can send it.
And can that be overlapped then on the frequency range that different species are using?
Yeah, you know, but this is where this is my own personal opinion. It becomes overwhelming as a biologist to figure out, okay, how are we impacting this species and that species and this species and that species? My approach at this point in time, and is one that was an idea that was developed by Lance Barrett-Leonard at the aquarium, is rather than try and guess how animals are going to be impacted, let's just set a limit. So for example, for the port of Vancouver that's going to do all this expansion, let's just say you can't increase the noise any more than what it is right now. So if you want to do this big expansion, you've got to be quieter if you're going to have more ships coming in. You've got to figure out a way. And again, this is like the Germany example. Guidelines or regulations will drive innovation and they'll make it quieter. So one important little factoid I should tell you, there's only one acoustic signature for an LNG tanker that I'm aware of, but they are as noisy as super tankers. So, but it was one done off on the East Coast. So.
But that you showed depends on speed, right?
Yes.
So you can get them to slow down, there's a lot less.
Yes, but particularly with LNG, there's pressure on them to go fast to maintain product, right? So there's some trade-offs there.
And then it's also very narrow here, right?
Mm-hmm. So you can have reverberation and things like that. But I will say, for many of these larger ships, cavitation starts at around 8 to 10 knots. If below 8 knots, typically they're quieter because they're not cavitating.
Well, two things. One is that as of very recently, wood fiber has committed to having the facility on land because they can't do it any other way. That's the reality. So that's good news because we won't have noise traveling from the liquefaction plant on the barge into the water. However, we will have the LNG, if it happens, the LNG carriers coming in once a month or less, hopefully, and they take once a week, sorry. And they take 24 hours to load, and they'll be running their engines during that time. So, just as you have been asking, I mean, who is going to be affected the most? Are they all going to be are they all going to run away? Is everyone going to run away, including herring, from regular 24-hour ship running?
Well, you know, there's a challenge there, and it's sort of like the southern resident killer whales. Do they run away because of all the noise we're putting in this area? Well, if there's fish around, they don't. But their calling has changed. It's gotten louder than previously. So there are impacts that way. We don't know if they're less able to find fish because they can't hear that echolocation because it's masked more. You know, I'd say you have a population that's not recovering. You need to think about all of the potential impacts that you have. So the herring may still come, but they may be more stressed, or they may not come. You know.
Is there any definitive source of information that one could quote to do with the herring, because they're the basis of the food chain. Everything eats them, and if they get scared away, then it doesn't really matter how the other marine mammals are affected, because there won't be food for them.
Yeah, I wished I could say that there was, but as far as I know, and I'd have to think, and I admit I don't think well late in the day, the last conference I went at, I don't think there was anybody working on herring specifically. But again, that's research that should be done.
It is, and with our provincial government, I don't think it would be very easy to just say, let's settle a noise level at such and such with their determination.
No, but one thing the Port of Metro Vancouver is being fairly proactive on is at least engaging in these kind of conversations. And there's a program called the Green Marine program. It's a green certification for ports and vessels, that sort of thing. And they have standards for emissions and things like that. And it's an incentive program. So if you follow the Green Marine's criteria, you can get benefits like reduced berthage fees, or you might get quicker access to unloading, things like that. So it's incentivizing changes in behavior. We're not there yet with the noise issue, but we're working, that's definitely on my agenda. I do want to tell you, one of the largest sources of noise around Vancouver, which I know isn't relative to you, but it's something you should think about, is BC ferries. And it's these large ships that BC ferries have what's called a variable rate propellers, which are great because they can be more efficient. But what they have is variable rate propellers on a shaft that turns at a fixed speed. So it means that the vessel, when it's sitting at the dock, the engine is running the whole time, even though the propellers the blades are angled in such a way so it's not moving forward, but the shaft and the engine just keeps turning, and that just puts noise right into the ocean, and they're very noisy. So as we increase awareness about this, we can hold industries, whatever, more accountable.
BC Ferries is putting up tenders for new ferries.
I'm aware of that.
Maybe we can pressure them to do something with that? Because I have an aluminum boat, and you would not believe the amount of noise from those Rennes, those Spirit class ferries, whatever they're called.
Yes.
I could hear them coming like a kilometer away.
Yes, so that's why I'm here talking to people. When you hear about these developments and they're having something to do with the ocean, think about what the noise is that's being produced.
Another question, if you had a tanker being pulled by a much smaller tug, would you expect the volume level to be more comparable to that of the smaller tug or the bigger tanker?
Tugs can be very noisy as well. With any, if the tug engine is running at full speed, so it's working at maximum capacity, it's very noisy. So actually one of the ways that they're trying to reduce noise in the offshore oil in the States is by engineering things so that things are actually overbuilt, so that the tug doesn't have to work at full capacity, that the bow thrusters don't have to work at full capacity. So that's the sort of thing, it really depends on the situation. So.
Just one back here.
Okay.
In regards to having an onshore facility, are there any studies that you know of that link or that have looked at the propagation of sound from heavy industrial machinery on land into the water? And what proximity, is there like a setback that should be?
Yeah, it's substrate and project specific. And it also, it's yes, if there is a development right on near the water, the sound will propagate through the ground and then into the ocean. Absolutely. The way that it does has to be assessed on an individual basis because sound moves differently through different substrates, and it depends what the source is. Are there individual studies? Not that I can think of right now, but I could probably. If you remind me or send me an email, I could put you in that direction. I could try to.
Okay, thanks. And also, is there like a vibration isolation strategy that could be implemented?
That's exactly it. So it's the mounts. Absolutely. And that's what they're doing they're recommending now with commercial shipbuilding. It's even things like using electric motors rather than diesel engines and things like that. So.
Thank you.
I've got a question right here. Sure.
My name is Bob Baker from the Squamish Nation. Way back when they had this chemical just across from where I live in Squamish, and we didn't do anything about it, but there was a few young boys we were working on a boom ground. A couple of them down there died there because the chemical was just coming in strong. But we don't want to have that again. This thing here that's happening now, it's who's gonna get hurt? We'll all get hurt. You know, we're trying to look after ourselves, this valley. I grew up here, right in here, just down the river here. And Pat Brennan was the mayor at that time. And he says, that's the worst thing I've ever done. It's okay, something like that to happen to the Squamish shore there. And he couldn't change it. So right now is the time that we gotta have a big say on this. No, we're talking about species, and we're the one that's gonna go. More or less.
Maybe that would be a good thing.
Yeah. No,
I meant that in joke, sorry.
that's a good target. Anyways, I worked on the boom ground down just in the waterfront, and the herring was just packed when it came in. There was herring all over there, and that mill was another one that killed all the herring. When they started using that chemicals to put over the lumber, and that spring there when I was working down there, I think it was about 1.5 feet thick of dead herring all the way up. And we're talking about herring that won't come back to the sound. This is a different thing again. I was a herring fisherman, a commercial fish. 40 years I was up there. And once you dump a herring, the fish will never come back. Never come back to this certain place. So we had to deliver all our herring. We have to give it away. So this is what another thing that's happening. You know, I don't. When I was living on the coast, and I slept on a boat all the time, you can hear the propellers going by all night when the big boats going by, different sounds, and didn't bother us at that time because we didn't know better what was going on. We never heard about these sounds. There was thousands of killer whales going by that I was on the Johnson Straits way up top end of Vancouver Island, and there were thousands of blackfish going through. They call it blackfishes, killer whales, and those other kind of whales. And I seen them whalers come in. It took them 1 week to kill all the whales right where we were. I couldn't believe it myself because they tied them all together just like they were logs. There were six across, and they had to tow them all the way up to the whaling station. And I seen that happen. I've seen a lot of things happen on the coast. Now what happened to the government, it didn't help nobody. See, this is what I'm worried about here. Is the government going to stop this, or what's happening? We're talking about the one up in Kenmouth too. It's going to kill the whole coast. Once it kills all that fish, there'll be no more. Once that fish dies on the ocean's going to turn dirty. The fish is the one that keep all the oceans clean. They live off the ocean. Anything that's around is cleaned up. And I see that because I see that's going to happen. But I'm really thinking about our own self here, and that doesn't matter what they do. I don't want to see it come through our territory here. That's something like that that's dirty. We didn't want them there, the pulp mill. We fought that for a long time. And then when they got rid of them, we thought we were free, that all the fish were coming back and everything was coming back. Now what's going to happen? We might as well say goodbye to it all. I do have a lot of say. We're going to have another meeting somewhere, and I think we're going to have one down our toilet hall. There's a lot of people there, because I wanted to see our leaders here tonight, to listen to what you have to say here. And I'm just going to pass it on what I heard today.